Welcome to lecture 2. In this lecture we are going to see how we can use inputs, and we can input text, numbers, vectors, matrices, and then we can do indexing and slicing operations on matrices. So to declare a variable you would use a variable name, an equal sign, and then the variable value. So to do this, let's look. So we declared our variable a as 1, and we can replace this by using it again, and the value is saved into the workspace. The text input can be saved just like a variable, but a text is a string, and each alphabet or each element has its position as number, and it's very important to know because when we are going to indexing and slicing, we must know what position a certain alphabet is there so we can replace it. So a text is added with commas, and the color of the text is changed to this pinkish or whatever it is. And you have to notice that on the right side in workspace you can see the size of this string. It's 1 by 18, like there are 18 columns and 1 row. And there can be 3 ways to add numbers to Matlab, and everything is in a matrix in Matlab. So there are scalars, which is 1 by 1 array. There can be vectors, which is 1 by n array or n by 1, and there can be matrices, which is m by n array. So the vectors are one-dimensional array and can be a column or a row array, and all array operations apply to them as well. And you can see that the array or the vector starts with the brackets, the braces they call it, and its dimensions are shown in size in the workspace. So we can see that the column is 4 by 1 array and the row is 1 by 4 array, and the matrix would be 4 by 3 array, I guess. Yeah, it's 3 by 4 array. So we have 3 rows and 4 columns. So a matrix is a 2-dimensional array or an n-dimensional array, because matrices can be multi-dimensional, and it can be over 2 dimensions, it can be 3 or 4, whatever it is. So but for now in this course we will only be using the 2-dimensional arrays, and they store data as tables, or even the tables are arrays. And this is the most important thing in linear algebra that we can be using. So there are these 4 critical operations that we can do to arrays or strings, and these are to look up a certain number within an array, to add a number to the array, or change or replace an element from array, and then finally to remove it or remove something from array. And the lookup is to assign a certain location of the element. For example, the third element in a vector A can be assigned to the C, and similarly to something else. So whatever we look up is assigned to the C variable here. So here we can declare a variable as 8 numbers, and it is a 1 by 8 array, and vector 2 is a column array, I guess. Yeah, now we can try creating a matrix. and we can try to look up for certain elements. So index 1 is my 7th place in my vector, and index 1 is end of the vector. So it's very important to see that how we use different things. For example, vector 2 4 is 4, and fourth element end is 8 as well. So we can slice this vector 1 from certain element to a certain element. Let's see, for example, we did it 2 to 4, and then yeah, that was wrong. So now slice 1 is my vector from 2 to 4 element, and we can do the same thing for slice 2 as vector 2, and we have to note that vector 1 was, or vector was, a row array or a row vector, and vector 2 was a column array. And then similarly we can see the array index for matrix, and we can see how many rows or what columns. So the 7th element in the matrix is 222 or 22. So what row or what column? Now we have 2 4 like we created for the indexing, and now we can slice it from 2 to 5 in rows and 3 to 4 in columns. Now we can see that it's in 2 to 5 in rows and 3 to 4 in columns. That we can see 2 3 3 3 4 3 5 3, and then similar thing for the other one, 2 4 3 4 4 4 and 5 4. And addition can be done by the same thing, and we can use a additional elements is equal to additional element, which is that one where a is our vector or matrix or whatever. So and we can do the same thing for slicing as well. So we use the same matrices that we created, and then we can do the same one to add elements to it. So we're going to add some element to slice 1. Let's see where does it add it to. So it was already 3 elements, and now we added more. So matrix 2 is just see the orientation and numbers. For example, 1 1 1 2 1 3 2 1 2 2 2 3. Now we're gonna add a third row to it. Third row and whatever column. And now we're gonna add the fourth row to it. Fourth column, sorry. And it has to be like 1 4 and then 2 4 and 3 4. And there we have our second matrix. And we can do it to different rows, different columns. We can just add different sets. And this will be very important when we are doing FEA using Matlab, because we would be inserting and removing certain elements at the boundaries, and changing is done by the same way that we have. And so now the fourth element of slice 1 is 5, and we want to replace fourth element to be 55. Now we can see that slice 1 is this one. Now we can do the same operation to a matrix with rows and columns. And now you can see that we can add a string. We cannot add a string to it because everything else was a number. And we cannot mix strings and numbers in one matrix. It's very important to understand that from element or from whatever row we have to the element, it's very critical in matrices. And finally we can remove it, and we can use the address of an element, and then we can use the braces, empty braces, to show that we need to remove it. For example, slice 1 is this one, and then we just use the empty braces to remove that element. Now 3 is gone, and we want to remove the sixth element. And you must notice here that we did not ask it to remove 6 from the row. We asked it to remove the sixth element. Now let's do for the second. Wow, because array slice is just one dimensional array. Now we just removed the second column of the array, and we can remove the entire column. You see that we said that everything in the second column. Thank you very much and happy learning.